Okay, so today we're going to do horizontal stretching and more characteristics of these absolute value graphs. So look at our equation here. Y equals absolute value of bx. In the previous video, we did one with a and c and d, right? Well, b is inside the absolute value bars, so it's with the x, which means it's going to be opposite of logic. So when you describe the b, the description is opposite of logic. But when you go to graph it, it's just going to be graphing the slope, and I'll demonstrate this for you. Now, opposite of logic, what do I mean? Well, I mean it's going to be a horizontal stretch if that b value is small, meaning if b is somewhere between 0 and 1, a fraction. Okay, so you wouldn't think a fraction is going to make it bigger, but it is going to horizontally stretch it. And what I mean by stretching is it's going to pull it this way, okay? Stretch it horizontally like an accordion. So vice versa, the horizontal shrink is when that b value is greater than 1. And when I say horizontally shrinking, it's pushing it in like this. And I'll show you how to graph this. It's not going to be that bad. So let's try this out in a couple questions. So it says graph the given function, state the requested characteristics. Okay. Look at this. Absolute value of 2x minus 3. So what's going on here? That 2x inside, it's going to be horizontal, but it's going to be opposite what I think. It's not going to be a stretch, it's going to be a shrink because it's greater than 1. So it's a horizontal shrink by, not by 2, but by 1/2. It's going to be the reciprocal of whatever that value is, okay? So make yourself a note. It's always the reciprocal. Now, that's the horizontal shrinking part. Now, what about the minus 3? Well, the minus 3 just means it's going down 3. We've seen that before. My vertex is going to be at 0, negative 3, which then means my axis of symmetry is going to be x equals 0. It's always a vertical line, so it's always x equals. And the 0 I get from the x coordinate of my vertex. Now let's graph this. If my vertex is at 0, negative 3, put my plus sign here or start my vertex there. Now let's use this 2 as my slope. So I go up 2 over 1. All right, so there you have it. It is horizontally shrinking it. Remember, a horizontal shrink means it's pushing the parent function, squishing it this way, okay? So what is difficult about this? What you have to remember is that the description is opposite logic, okay? The description, you're using the reciprocal, but when you actually graph the slope, you're using the number as it is in the equation. Let's try another one. Number 2. Negative 1/2, absolute value of 1/2 x minus 4. All right, so let's take this piece by piece. What does the negative in the front mean? That means it's going to be reflected over the x-axis. That's a vertical reflection. Okay, the 1/2 is going to be a stretch. It's going to be a horizontal stretch by 2. Remember, take the reciprocal. And the minus 4 means it's going to move it down 4 units. So my vertex is no longer at 0, 0, but it's at 0, negative 4. Okay? And my axis of symmetry is going to be x equals, again, take that x value and just bring it on down. X equals 0 is my axis of symmetry. So it's 0, negative 4. 1, 2, 3, 4. Now, it's going down, and I'm going to use the 1/2 as my slope. So I go down 1 over 2, down 1 over 2, and then I go like this. All right, so notice it's stretching this by pulling it this direction. That's the stretching notation. You don't have to write those extra red arrows or anything. I'm just trying to help you understand why do we say stretch? Well, it's stretching it out like an accordion. Let's try number 3. y equals 2 times the absolute value of x minus 4. Now that 2 is on the outside, which means it's going to be vertical. And this one, since it's on the outside, it goes with logic. So it's going to be a vertical stretch by 2. The minus 4, remember, it's inside the brackets, the absolute value brackets. So it's going to go opposite logic. So instead of going like we think negative, it would go right 4. So my vertex is going to go right 4, but it's not going up or down. It's just 4, 0. Therefore, my axis of symmetry is x equals 4. So let's move this over 4. 1, 2, 3, 4. And now I apply my slope of 2. 1, 2, 1, 2. All right, there we go. Let's try another one. Absolute value of 4x plus 2. All right, that 4x is inside the absolute value bars, so it's going to be horizontal, and it's going to be opposite logic, right? So it's going to be horizontal. It's 4, so it's greater than 1, which means it's going to be a shrink by 1/4. And then what is a 2 doing? Well, that's going to move my vertex up 2 units. So my vertex is going up 2. That means it's at 0, 2. Therefore, my axis of symmetry is x equals 0. Now let's apply that 4 slope in there. 1, 2, 3, 4. Not too many more points we can add in this, but you can see here's what's going on. All right, so remember the horizontal shrink. What does that mean? It's shrinking in this way. That's what it's doing. Let's try number 5. This one's different. Look at this. Y equals the absolute value of negative x. Now the negative is on the inside. So it's going to be a horizontal reflection, okay, which means horizontal reflection, or you can say over the y-axis, okay? It's horizontally reflecting over the y-axis. Well, how does that change anything? Well, notice nothing is changing to my x, and there's no moving up or down, left or right. Therefore, my vertex is staying exactly the same. And really, if you think about your parent function, if you flip it horizontally, it's symmetrical about the y-axis, so it's going to look exactly the same. So if I take my original points and graph this horizontal reflection does not change the shape. Notice, it doesn't change the shape. Okay, it doesn't flip it upside down, it doesn't change the shape, and the reason is you are just flipping it this way. That's what the horizontal reflection is doing. And so since it's symmetrical, you're good. Everything's good. My vertex didn't change. Axis of symmetry is the original, x equals 0. So now another type of equation or question you're going to see on your paper today is where you have to write the equation from the graph. We've seen this before. This is more practice of the same. So I want to look at my vertex first. Where's my vertex? Well, it went down 1, but it's still at x of 0. So 0, negative 1. And I notice that it's flipped upside down. So it's going to be y equals, and I put a negative in the front to flip it upside down. That's that vertical reflection. And then x didn't change, didn't go left or right, so I don't need to do anything with my x besides leave it in the absolute value bars, and then bring down the negative 1. All right, that's just graphing it. Okay, on the back of your notes, we're going to do very much the same thing, but without the graph. Notice it says find each of the requested features algebraically, and you might want to sketch the graph to check your work. So we're going to do it algebraically, and walk through each of these steps. So let's look first at number 7 here. Y equals negative absolute value of x plus 1 plus 7. Now, the vertex, hopefully you've noticed a pattern here. The vertex comes from what's happening to my x and what's going on back here. Remember the parent function vertex is 0, 0? So if this is plus 1, inside there it goes opposite logic. So my vertex would be a negative 1. I change the sign. This vertical movement up and down goes with logic, so it stays the same. So there's my vertex. So change the sign of this, what's going on inside the parentheses, and don't change the sign of that. Axis of symmetry is going to be x equals whatever that x value is. Now, x-intercept and y-intercept. Okay, it's been a minute since we did this at the very beginning of the year, but remember x-intercept means there's an x value here and a 0 over here. So how do I remember this? You want to keep what you're looking for. I want to keep the x in the equation, but I'll plug in a 0 for y. So if I do that, it looks like this. 0 equals negative absolute value of x plus 1 plus 7. Now, I don't personally like the 0 on the left, so I'm just going to switch it over here on the right, so it looks like that. Now let's solve it. Remember when we solved absolute values, we always have to isolate that thing first. So I need to get rid of the negative, and I need to get rid of the 7. So I'm going to start by moving my 7 over to the right. So I have negative absolute value of x plus 1 equals negative 7. I want to get rid of that negative in the front. That's not helping me at all, so I'm going to divide by negative 1. Now I have the absolute value of x plus 1 equals a positive 7. Now, when we do absolute value, if you recall, we're going to take what's inside x plus 1 and set it equal to the negative version, write the word or, and then insides again, but this time equal to the positive version, and then solve these. So x, if I subtract 1, equals negative 8. If I subtract 1 here, x equals 6. So these are my x-intercepts. So I write them as coordinate pairs, 6, 0, and negative 8, 0. So I have 2 x-intercepts. Okay, hopefully that makes sense to you that your graph could indeed cross in 2 locations, right? But what about y-intercept? Well, the y-intercept, if you recall, is going to be 0 and a y value. So keep the y and replace the x with 0. So go back to my original equation. I'm going to keep y, and I'm going to replace x with 0 and solve it. So I have negative absolute value of 1 plus 7. Well, the absolute value of 1 is 1. Times that negative makes it negative 1 plus 7 gives me 6. So then my y-intercept will be 0, 6. Let's try another one like this. Y equals the absolute value of 2 times the absolute value of x minus 5 minus 4. All right, so vertex, remember I'm going to take what's happening in here and reverse the sign. So if it's minus 5, I'm going to make it plus 5. This, I'm going to leave it alone, keep the sign the same. Axis of symmetry, take that x value of my vertex and set it equal to x because it's a vertical line. Now we do the algebra part, x-intercept. So I'm going to keep the x in the equation and put a 0 in for y. But this time I'm just going to put it on the right side. 2 times the absolute value of x minus 5 minus 4 equals 0. So let's solve this out, isolating our absolute value. 2 times x minus 5 equals 4. Divide by 2. So absolute value of x minus 5 equals 2. And now we split it up. So x minus 5 equals negative 2, or x minus 5 equals positive 2. So let's solve it. So x is 3, or x is 7. So my y-intercepts are 3, 0, or 7, 0. There's 2 different x-intercepts. I think I said y-intercepts, but they're x-intercepts. Now let's do y-intercepts. Remember, I'm going to plug in a 0 for x. I'm going to leave y there, and I'm going to plug in 0 for x. So 2 times 0 minus 5 minus 4. 0 minus 5 is negative 5 minus 4. Absolute value of negative 5 is 5 minus 4. So that's 10 minus 4, which is 6. So my y-intercept is 0, 6. All right, these are the types of problems you're going to see on your assignment. Hopefully this gives you some good practice, and let me know what questions you have.